All animals that get high in the wild, dolphins. The first mistake people make is assuming altered states in animals are a human invention. They are not. The wild has its own chemistry, and sometimes the chemistry changes behavior in ways that look uncannily familiar. The most discussed example comes from dolphins interacting with pufferfish. The public version sounds almost playful. A dolphin, a dangerous fish, and a strange repeated behavior that appears to leave the animal in an unusual state. The scientific version is more careful, but the pattern is strong enough to matter. Dolphins have been observed handling the fish deliberately, passing it around, and returning to the interaction again and again. That is the key visual. The animal does not seem to stumble into the compound once and retreat. It returns. The dolphin returns to the toxin again and again. Whether that qualifies as intoxication in the human sense remains debated, but the behavior is difficult to explain away as accident. Pufferfish can release tetrodotoxin in small amounts, and that chemical is powerful enough to alter behavior at low doses. This is where the documentary answer becomes more interesting than the joke. Dolphins are social, curious, and capable of repeated experimentation with novelty. The behavior is not just about chemistry. It is about a mind meeting a chemical world and choosing, in some form, to stay there. Nature was altering consciousness long before humans had a word for it. The dolphin case is compelling because it looks less like a prank and more like a pattern. Reindeer are one of the clearest examples of wild animals interacting with psychoactive fungi. In Arctic regions, they have been observed consuming Amanita muscaria, the fly agaric mushroom, which contains compounds capable of altering behavior. The visual part matters. This is not a laboratory event or a one-time curiosity. It happens in seasonal landscapes where fungi are simply part of the food environment. The reindeer moves through the tundra, finds the mushroom, and eats it as part of normal foraging. Then the behavior shifts. The cause is straightforward. Bioactive compounds in the mushroom affect the nervous system. The result can be changes in movement, alertness, and coordination. The public often turns this into folklore, but the underlying biology does not need myth to be strange. The animal is eating a natural compound that changes state. A useful way to think about this is scale. In a large herd, one altered animal is noticeable. Several altered animals become a scene. The group no longer moves with the same precision. The shift in behavior becomes visible from a distance. Not because the animal has become like a human, but because chemistry has entered the routine. Fermentation existed long before civilization. Fungi did not wait for people to invent intoxication. The reindeer story reminds us that the wild has always contained compounds that can tilt consciousness without asking permission. Elephants enter this topic through something much more mundane than legend suggests. Fermented fruit. A large animal consumes fruit that has changed chemically, and the result can be a temporary change in behavior that becomes easy to notice because the body involved is so big. The common mistake is to treat that as a myth about animals getting drunk. The better version is simpler and more visual. An elephant eats fruit. The fruit has fermented. The elephant's movement changes. The path becomes less steady. The head sway looks different. The pace no longer matches the animal's usual confidence. That matters because elephants are so physically massive that even a mild change in coordination is visible. A small shift in state becomes a scene. The viewer can see it instantly. The body still has power, but the timing is off. The creature is present, but not exactly aligned with itself. There is also an emotional edge to this case. Elephants are already associated with memory, intelligence, and long behavioral arcs. Put fermentation into that picture and the result is unsettling, not because it is dramatic, but because it is ordinary. The environment creates the compound, and the animal simply eats it. The forest does not need a human concept of intoxication to produce one. It only needs chemistry, fruit, and time. The elephant case makes that feel larger than it should. Birds are one of the most visually obvious examples because the effects can be seen in motion. When fruit ferments, it can produce alcohol-like effects, and birds that consume it may lose coordination, behave erratically, or land badly. That detail matters. The bird does not just seem off. It can miss a branch, clip a landing, or sit motionless in a place it would normally avoid. The body is still in the air, but the system is no longer running with the same precision. That is the kind of image that stays with the viewer. The cause is not mysterious. Seasonal fruit changes chemical state. The animal eats it. The nervous system responds. Because birds are small and highly coordinated, even a slight shift can produce a visible difference in flight behavior. The result may look like drunkenness, but in ecological terms, it is just chemistry meeting a bird at the wrong moment. This is one of the strongest examples of how the wild can create altered states without any human framing at all. The fruit does not care. The bird does not need a story. The effect happens, and the viewer sees the consequences immediately. That is what makes birds useful in the structure of the video. They bring the topic down from abstraction into motion. One bad landing is often more memorable than a paragraph of explanation. Wallabies and possums marsupials add a different texture to the same idea. Wallabies and possums can interact with fermenting fruit or plant material that has changed chemically in the wild. The result is often subtle, but still visible. Slower movement, unusual stillness, or a pause that feels out of place. This is the kind of case that rewards careful documentary language. It is not about turning the animal into a punchline. It is about recognizing that altered states do not need to be theatrical to be real. A small change in chemistry can change the rhythm of a body. The animal may still be functioning, but not at the usual speed. There is a quiet discomfort in that. The animal is not performing for a camera. It is simply living in a chemical landscape where fermentation and plant compounds can shift behavior. The effect may be temporary, but it is real. The broader lesson is that getting high in the wild is not a rare exception. It is one possible outcome of feeding in a world where food is never chemically neutral. The wallaby and possum examples are important because they turn that fact into a scene the viewer can imagine. The forest produces chemistry whether anything understands it or not. Why it still happens, animals get high in the wild because the wild is chemically active. Plants produce defense compounds, fruits ferment, fungi generate bioactive molecules. Marine life can contain toxins that alter behavior. The animal moving through that environment is constantly making chemical choices, whether it knows it or not. There is also opportunity. If a substance is available and the animal does not avoid it, the behavior can repeat. That does not always mean the animal is deliberately seeking intoxication in the human sense. It may simply mean the compound changes the state in a way the animal does not immediately reject. That uncertainty is where the topic gets deeper. It is easy to make this into a joke. It is harder and better to see it as a clue. Maybe altered consciousness is not just a human cultural event. Maybe it is a biological possibility that appears wherever nervous systems meet the right chemistry. That idea is unsettling, but it is also useful. It keeps the video from becoming only a list of odd behaviors. It becomes a reflection on how often life changes state when chemistry says so. If you made it this far, you already see the pattern. Animals do not need human drugs to enter altered states. Sometimes it is a mushroom. Sometimes it is fermented fruit. Sometimes it is toxic prey. Sometimes it is chemistry the animal meets in the wrong place. And sometimes the most striking part is not the effect itself, but the image of a body moving differently because the world around it has changed chemically. If you want more of this precise, strange, visual animal behavior from the wild, subscribe. And one more thing. Which moment stayed in your head the longest? The dolphin returning to the toxin, the reindeer and the mushroom, the elephant on fermented fruit, or the bird missing the landing? Tell us below.